As the Department of Defense seeks to define its role in the post-Cold War era, DoD natural and cultural resource managers are experiencing new challenges and opportunities. Prominent among these challenges is the desire to take resource management beyond legal compliance to long-term stewardship. In response to this challenge, the DoD Legacy Resources Management Program provides an unprecedented opportunity for natural and cultural resource managers to employ new ways to meet daily mission requirements as well as resource stewardship. Archaeological Assessments, a cultural resource management firm based in Nashville, Arkansas, working with a number of earth scientists, many from the U.S. Army Engineer Waterways Experiment Station in Vicksburg, Mississippi, has developed a cultural resource management framework that meets this challenge. Developed for use by the U.S. Army Engineer District, Little Rock, at the Fort Chaffee Military Garrison, the Pine Bluff Arsenal, and other project area locations within the Arkansas and White River valleys, this framework holds great promise for application across the broad spectrum of resource management concerns.
As I look back on the many different projects we have undertaken in conjunction with our earth science colleagues, I can say that without a doubt the most important contribution they made to our joint efforts was to teach us that the landscape within which we were conducting our investigations was not simply a random collection of unrelated natural and cultural features, but was rather an integrated and dynamic whole. This understanding of the landscape as a single unified system now serves as a conceptual framework within which we conduct all of our work. The development of this framework begins with an analysis of a project area's landscape produced by earth scientists, most often by geomorphologists and soil scientists. The level of effort and amount of detail involved in this analysis has been tailored to specific project needs and available support. Typically, this analysis is embodied in a report which consists of two parts. One part is composed of a narrative which describes the area's principal landforms, identifies the major geomorphic processes which have created and modified these landforms, and summarizes the area's apparent geomorphic history. The second portion of the report consists of a set of USGS quadrangle sheets, usually at a scale of 1 to 24,000, onto which the location of the area's major landscape elements have been mapped. Together, the narrative and map components identify and describe the geomorphic systems responsible for the creation of the area's landscape, and as such constitute the first stage in the development of a spatial model for our area's landscape, a model which will become increasingly sophisticated and useful as our investigations proceed. Thus far, most of our work has been within landscapes formed by two basic geomorphic systems, hill slope and fluvial systems. At Fort Chaffee, the hill slope system was divided into three basic landforms: ridge slopes, eroded ridge slopes, and interridge valleys. The fluvial system at work on Fort Chaffee was divided into two basic components: the Arkansas River Valley and the smaller tributary valleys. The Arkansas River Valley contained well-developed Pleistocene and Holocene age terraces, as well as point bars, lateral bars, natural levees, and crevasse splays. Within the tributary valleys, such as Fashgrass Creek, features such as active and abandoned channels, tributary terraces, and tributary floodplains were delineated. Since, like other resources, the nature and location of cultural resources are inextricably tied to the geomorphic systems within which they are set, a basic understanding of an area's geomorphic systems is essential if we are to understand the distributional patterns of the resources we are seeking to manage. This is particularly true for fluvial geomorphic systems, which, because of their inherent dynamism, often contain landforms, and therefore cultural resources, of significantly different ages. For example, Throughout the Arkansas River Valley, there are extensive areas composed of lateral accretion deposits laid down entirely during the last several decades. Obviously, the types of cultural and other natural resources present on these youthful landforms are drastically different from those present on elements of the landscape which were created centuries or millennia earlier. Also within the Arkansas River Valley, there are locations at which older landforms are currently buried beneath much younger deposits. A prime example of this is the Arkansas River Terrace system at Fort Chaffee. Here, a series of riverbanks formed in the mid to late Holocene period are presently covered with increasingly younger natural levee deposits. Post-settlement alluvium is another particularly important fluvial deposit which occurs extensively in the Arkansas and White River drainages. This deposit, often called simply PSA, was created by the erosion associated with widespread land clearing in the 19th and 20th centuries. In many places, this deposit forms a blanket covering older active and relic floodplain surfaces which often contain the extensive archaeological remains of the late prehistoric residents of the region. While the examples just presented illustrate the importance of understanding the significance of individual elements of an area's geomorphic systems, it is even more important for us to emphasize the necessity for cultural and natural resource managers to understand that the landscape is not just the sum of its parts, but an integrated and dynamic whole. Indeed, our earth science colleagues have convinced us that if we wish to understand the nature and distributional patterns of an area's cultural resources, it is necessary for us to view them as parts of a larger whole, a perspective which has allowed us, for the first time, to perceive the importance of the physical systems within which cultural resources are set. In our experience, this perspective was most easily gained when we began to use the geomorphologically annotated quadrangle sheets as the map base onto which we depicted and analyzed the distribution of recorded cultural resources. By this simple act, we began the process of developing a spatial model which would, over time, include many other types of cultural data. Thus far, we have been successful in combining our landscape models with two other types of data. One data set relates to the distribution of known archaeological sites, primarily prehistoric archaeological sites. These data are usually on file with appropriate state and/or federal agencies. The other data set consists of information about the built environment and past land use practices of the area's Euro-American residents, which is dispersed within a variety of public and private documentary, cartographic, photographic, and oral historical sources. In the process of developing such data sets, it has been possible for us to incorporate into our team of archaeologists and earth scientists other colleagues with different types of expertise, including historians trained in documentary research, as well as specialists in aerial photography and image analysis. The interaction between the different team members has added considerably to both the efficiency and comprehensiveness of our efforts, so that little by little, the whole has become significantly greater than the sum of its parts. Within this type of interaction, particular data sets are carefully and critically developed into separate coverages, which we then overlay onto our landscape model. This overlay process provides a number of immediate and direct benefits, the most obvious of which is the identification of locations for elements of an area's prior built environment, such as roads, houses, schools, and churches. But not only does this provide information about where particular elements of the built environment were located, a comparison of coverages constructed for particular periods provides insight into how the settlement pattern of an area has changed through time. Such insights are particularly important in assessing the relative significance of different portions of the Euro-American archaeological record. Another major benefit which comes with the overlaying of such Euro-American coverages is that they provide us with an indication of how recent land use practices may have modified the natural landscape. This modification is exemplified at Fort Chaffee in the way in which farmers placed ever-increasing amounts of acreage into the production of row crops, and the creation of an extensive system of farm terraces built in an attempt to halt the widespread soil erosion which resulted from earlier agricultural practices. Analysis of the effect of such modification on the landscape has particular importance for the assessment of how such activities may have altered the archaeological remains created by the area's prehistoric occupants. While the data which compose these different coverages will, of course, vary from location to location, it has consistently been our experience that by integrating these kinds of data within the framework provided by the geomorphologically constructed model of the area's landscape, we have structured a database which is invaluable in organizing all future cultural resource management activities. This was certainly the case in our work at both Fort Chaffee and Pine Bluff Arsenal, where we used what might be described as our culturally annotated landscape model in several ways. First of all, by combining our professionally derived stratification of the installation's landscape with information about the location of previous archaeological investigations and recorded sites, we were able to develop hypotheses regarding the way the prehistoric archaeological record might be distributed across particular elements of this landscape. We predicted that at Fort Chaffee, individual elements of the prehistoric archaeological record were heavily clustered along the tributary terraces and on the colluvial fans, but were much more dispersed across the ridge slopes and interridge valleys. Further, we expected that within much of the Arkansas River Valley portion of the installation, this record would be buried to considerable depth. In addition, we were able to identify extensive areas where the landscape was sufficiently young or so extensively modified over the past few decades as to preclude the presence of significant cultural resources. With this information, we were able to design a program which would sample each of the various landscape elements to test the value of these predictions. Moreover, the landscape model also provided guidance in the location techniques to be used, which involved extensive shovel testing in areas covered by post-settlement alluvium and soil coring along the former Arkansas River bank lines. In planning our strategy to test these projections, we incorporated data about the previously existing built environment and Euro-American land use. By doing so, we were able to develop a combined survey strategy designed not only to test and refine our hypotheses about the distribution of the prehistoric archaeological record, but also to assess the accurateness and comprehensiveness of the documentary, photographic, and cartographic sources related to the Euro-American archaeological record. Once our strategy was developed, we were ready to begin our initial extensive programs of fieldwork. At Fort Chaffee, this consisted of two different sets of activities. The first was an initial survey effort covering about 20% of the installation. The second was a program of site evaluation, which was also designed to meet a number of particular installation development needs. This program of site evaluation, which included the participation of several earth scientists, had three very positive benefits. It not only helped to clarify issues of site integrity at specific locations, it provided information useful in estimating the integrity of other sites in similar settings. Moreover, this effort generated a wealth of data related to the nature and rates of the varied landforming processes at work on the installation's ridge slopes, colluvial fans, natural levees, and tributary terraces, which were subsequently used to refine the installation-wide landscape model. Using data from these site-specific investigations and from the 20% survey, we evaluated our distributional hypotheses and found that with only minor corrections, our projections regarding the distribution of the prehistoric archaeological record were sufficiently accurate to predict the nature and location of these types of cultural resources. In addition, we discovered that when considered as a whole, the existing documentary, cartographic, and photographic evidence provided a highly accurate and comprehensive account of the installation's prior built environment. Because of its coherent and comprehensive structure, it was an easy matter to integrate these new data into the framework provided by our initial landscape model. Once this was done, we were in possession of a comprehensive, field-validated model depicting the way in which both the prehistoric and the Euro-American archaeological records were distributed across the installation landscape. This provided the framework within which we established the basic parameters for the installation's continuing program of cultural resource management, a program which has steadily moved away from the management of cultural resources as single entities toward their management as elements of a more comprehensive system. Since this framework was organized in a spatially coherent manner, it provided the context within which the installation could address both its short-term and long-term management needs, particularly as these related to the identification and evaluation of specific cultural resources. In the short term, our culturally annotated landscape model provided the context for and incorporated feedback from the seemingly never-ending stream of small projects associated with the installation's daily management. For example, at Fort Chaffee there are currently a large number of active oil and gas leases, and the processing of permits for the construction of energy exploration and production facilities is a constant activity within the environmental branch. In assessing the potential for adverse impacts to significant cultural resources by the construction of drilling facilities and transmission lines, we have used our culturally annotated landscape model to determine when site location efforts are needed to be conducted, and if such efforts were warranted, the type of locational strategy to be employed. Once completed, the results of these small-scale efforts were incorporated into our growing understanding of the way cultural resources were distributed across the installation. This approach also proved to be invaluable in developing the programs of site location and evaluation designed to complete Fort Chaffee's inventory of significant cultural resources. This program has been in operation since 1986, and during the past 6 years, the basic site inventory for the entire 72,000-acre installation has been completed. This was accomplished through a series of carefully designed pedestrian surveys whose locations and methods were determined using our culturally annotated landscape model. The first of these surveys targeted the Vashgrass Creek Valley, where we believe the prehistoric archaeological record was highly concentrated and where there was a strong likelihood for the presence of intact, buried archaeological deposits. As was the case in our 20% survey of the installation, the cultural resources we recorded in the Vashgrass Creek Valley matched very well with what we had predicted. Subsequent site evaluation efforts within the Vashgrass Creek Valley, again undertaken with the assistance of our earth science colleagues, confirmed the integrity of a number of the sites in this area. This work also provided important information about the nature of both the landforms and the landforming processes within this portion of the installation, information which was used to refine our understanding of the installation's landscape and geomorphic systems even further. This program of site evaluation within the Vashgrass Creek Valley was followed by a number of efforts designed to gather further information about the installation's Euro-American cultural resources. These efforts included further, more extensive investigations into the available documentary, cartographic, photographic, and oral historical resources, all of which provided us with a better understanding of how the elements of the Euro-American built environment had been distributed across the landscape, and an increased appreciation of how 19th and early 20th century land use practices had modified the natural landscape. Following this round of site evaluation and data acquisition, we undertook a final major survey effort designed to complete the installation's basic site location program. This work was finished in 1990. Using the methodology outlined above, the number of sites recorded by the Cultural Resource Management Program at Fort Chaffee has increased from the 7 sites recorded at the beginning of 1987 to a total of 876 sites at the end of 1992. In addition, over 70 sites, both prehistoric and Euro-American, have been formally evaluated to determine their eligibility for nomination to the National Register of Historic Places. And at the present time, there are 89 locations on the installation which are currently considered as significant or potentially significant. All of this has been accomplished within a 6-year period and for a price that was considerably lower than $10 per acre. In closing, we would like to emphasize that above and beyond all of the practical benefits which we believe can be derived from this landscape approach to cultural resource management, it is the insight that cultural resources are elements within a more comprehensive system, which has the most far-reaching consequences for the development of programs for which stewardship, rather than compliance, is a primary management goal. Admittedly, we are just beginning to glimpse what it may mean to manage our resources from such a holistic perspective. Nevertheless, we have no doubt that this approach will enhance our ability to protect archaeological and historical sites, and increase our insight into the lifeways and cultural patterns of the people responsible for the creation of these resources. Perhaps it will even allow us finally to turn our attention to the development of ways to make this portion of our cultural heritage increasingly accessible to a wider and wider public, which is, after all, what stewardship is all about.